When we look up at the night sky, what we see is not just stars. It is also the echo of an ancient question. Are we alone in the universe? The Milky Way galaxy is estimated to contain hundreds of billions of stars and potentially trillions of planets. But in a universe this vast, is Earth truly the only place where life has emerged? So far, Earth is the only habitable planet we know of. But does that mean it is unique, or simply that we have not yet discovered the others? In recent years, scientists have been searching for clear answers to this question, and this search has introduced us to a new concept: Earth 2.0. Earth 2.0 does not mean an exact copy of our planet. The term is used to describe worlds that could possess liquid water, have an atmosphere, orbit their star at the right distance, and theoretically support life. In short, these are alternative worlds that humanity might one day consider habitable. So, why now? Because Earth is changing. Climate change, a growing population, diminishing resources, and global environmental problems are forcing humanity to confront a serious question for the first time. What if Earth becomes uninhabitable in the future? The answer to this question is no longer found only in science fiction. It is now at the center of scientific research. Over the past 20 years, NASA and other space agencies have discovered thousands of exoplanets, and some of them may possess conditions that are even more favorable for life than those on Earth. In this documentary, we will explore the planets known as Earth 2.0, why scientists believe some worlds may be more promising than our own, and whether humanity's future could lie among the stars. To make sure you don't miss documentaries like this, based on science, depth, and real data, don't forget to subscribe to the channel and like the video. Now, let's look beyond Earth. Describing a planet as habitable does not mean that life definitely exists there. The term refers to whether a planet possesses the basic conditions required for life to emerge and be sustained. When scientists define these conditions, they use life on Earth as the reference point, because so far, Earth is the only example of life we know. One of the primary criteria is the habitable zone, also known as the Goldilocks Zone. This region describes the area around a star where a planet is neither too close nor too far away. If a planet is too close to its star, surface water evaporates. If it is too far, water freezes completely. Within the habitable zone, temperatures allow liquid water to exist, and this represents a critical threshold for life. So why is liquid water so important? Because all known living organisms depend on water. Water enables chemical reactions, transports nutrients and energy, and helps maintain cellular structure. For this reason, when scientists search for life beyond Earth, they first focus on environments where liquid water could exist. Frozen or fully vaporized water greatly reduces the likelihood of life. However, water alone is not enough. A planet's atmosphere plays a vital role in habitability. The atmosphere regulates surface temperature, filters harmful radiation, and contains gases essential for life. Oxygen, for example, is necessary for complex life forms. Carbon dioxide helps retain heat through the greenhouse effect. The ozone layer blocks ultraviolet radiation from the star, protecting the planet's surface. A planet without an atmosphere lacks these protections and is generally inhospitable to life. One of the most important factors in preserving an atmosphere is a planet's magnetic field. Earth's magnetic field deflects charged particles from the sun, preventing the atmosphere from being stripped away into space. Mars is a striking example. Once thought to have had water and a thicker atmosphere, Mars lost much of its magnetic field, and with it, most of its atmosphere. As a result, the planet became cold and largely uninhabitable. Another critical factor in habitability is the type of star a planet orbits. Not all stars are the same. Red dwarf stars are the most common type of star in the universe and can burn for extremely long periods. However, they often produce powerful radiation flares. These flares can strip the atmospheres of nearby planets. Sun-like stars, by contrast, emit energy more steadily. This stability allows planets to maintain consistent conditions over long periods of time. One of the main reasons Earth has remained habitable for billions of years is the stable nature of the Sun. When all of these factors are considered together, habitability depends on an extremely delicate balance. The right distance, the right temperature, a protective atmosphere, a strong magnetic field, and a suitable star. Without all of these conditions, it is very difficult for a planet to support life. This is why scientists are highly selective when searching for Earth-like worlds in the universe, because habitability is not a coincidence. It is the result of a rare and complex cosmic alignment. Among the thousands of exoplanets discovered so far, some stand out in particular to scientists. These planets do not only resemble Earth under certain conditions, they may even possess characteristics that make them more habitable than Earth itself. These worlds were not observed directly through telescopes. Their existence was revealed through subtle fluctuations in starlight, precise measurements, and years of continuous observation. NASA's Kepler and TESS space telescopes have played a crucial role in the search. Now let's take a closer look at the leading candidates closest to becoming Earth 2.0. Kepler 452b, Earth's larger cousin. Kepler 452b is located approximately 1,400 light-years from Earth. The planet orbits a star that is very similar to our Sun. It is about 60% larger than Earth, placing it in the category of so-called super-Earths. Kepler 452b lies within its star's habitable zone, increasing the likelihood that liquid water could exist on its surface. The fact that it orbits a Sun-like star is a significant advantage for long-term climate stability. However, its larger size also presents a potential risk. Stronger gravity could result in a thick and dense atmosphere, which may make surface conditions less favorable for life. Kepler 62f, the possibility of liquid water. Kepler 62f is located approximately 1,200 light-years from Earth. It orbits a star that is smaller and cooler than the Sun. Its size is relatively close to that of Earth, making it a strong candidate for a rocky planet. The planet lies near the outer edge of its star's habitable zone. If it has a sufficiently strong greenhouse effect, liquid water could exist on its surface. The greatest uncertainty is the thickness and composition of its atmosphere. If the atmosphere is too thin, the planet could become an extremely cold and inhospitable world. TRAPPIST-1e, one of the most promising candidates. TRAPPIST-1e is located approximately 40 light-years from Earth, remarkably close by cosmic standards. It is one of 7 planets orbiting the ultra-cool red dwarf star, TRAPPIST-1. The planet's size, density, and mass are very similar to Earth's. Scientists believe it could have a rocky surface, liquid water, and a stable atmosphere. However, there's a serious risk. Red dwarf stars are known for producing powerful radiation flares. If the planet lacks a strong magnetic field, its atmosphere could be gradually stripped away. Proxima Centauri b, our closest neighbor. Proxima Centauri b is located just 4.2 light-years from Earth, making it the closest potentially habitable exoplanet discovered so far. It orbits the red dwarf star Proxima Centauri. The planet lies within the habitable zone and has a mass similar to Earth's. In theory, liquid water could exist on its surface. However, the extreme activity of its host star poses a major threat. Intense radiation and stellar flares could erode the planet's atmosphere. For this reason, Proxima Centauri b is as risky as it is promising. TOI 700d, a planet highlighted by NASA. TOI 700d is located approximately 100 light-years from Earth and was discovered by NASA's TESS Space Telescope. This planet also orbits within the habitable zone of a red dwarf star. Its size is nearly identical to Earth's, and it is likely to be rocky in composition. Scientific models suggest that, with a suitable atmosphere, oceans could form on its surface. Once again, stellar activity remains the primary risk factor. Whether the planet can retain its atmosphere over long periods of time is still uncertain. All of these planets show us one thing: Earth may not be a solitary exception in the universe. However, habitability does not depend on a single trait. It requires multiple delicate conditions to be met simultaneously. These worlds may be far beyond our reach today, but the answers to questions about humanity's future may very well be hidden on the surfaces of these distant planets. Even the most promising Earth 2.0 candidates we know today are dozens, hundreds, or even thousands of light years away from us. And this brings us to a fundamental challenge: the light year problem. A light year is the distance light travels in 1 year. Light moves at 300,000 kilometers per second, yet even reaching one of the closest candidates, Proxima Centauri b, would take tens of thousands of years with our current technology. Humanity has not yet reached a level of speed that would allow interstellar travel. One of the solutions scientists have considered is the idea of generation ships. In this scenario, a spacecraft embarks on a journey lasting hundreds of years. The generation that begins the voyage would never reach the destination, but their children and grandchildren might arrive at the new world. While theoretically possible, this concept presents enormous challenges in engineering, biology, and social sustainability. Another option is to make an existing planet habitable. Terraforming. Terraforming aims to alter a planet's atmosphere, temperature, and surface conditions to create an environment similar to Earth. This idea is most often discussed in relation to Mars. Mars is relatively close, has a day length similar to Earth's, and contains frozen water on its surface. However, its atmosphere is extremely thin, and its magnetic field is weak. With today's technology, fully transforming Mars into an Earth-like planet does not appear feasible. So should our goal be Mars or distant exoplanets? The realistic answer is this: in the short term, Mars. In the long term, interstellar worlds. Exoplanets may already be naturally habitable, but for now, distance remains the greatest obstacle. All of this raises another question: is this science or science fiction? The answer lies somewhere in between. There was a time when traveling to the moon was considered science fiction. Today, there are concrete plans to send humans to Mars. Interstellar travel is not currently possible, but declaring it impossible would not be scientifically accurate either. Human history is the story of pushing boundaries. Reaching Earth 2.0 may take centuries, perhaps even millennia, but as long as we continue to look up at the sky, the possibility remains. And perhaps, one day, the first humans watching a sunrise on another planet will ask the same question once again: were we ever truly alone? We are searching for new worlds in the depths of the universe. We talk about the possibility of Earth 2.0 and study planets orbiting distant stars. But in the middle of all this exploration, there is one truth we must not forget. Earth is still the best planet we have. None of the worlds we have discovered so far fully possess the richness of life that Earth offers, with its oceans, complex ecosystems, balanced atmosphere, and billions of years of climate stability. While we debate the possibility of living on other planets, Earth continues to exist as living proof that life is possible. So why do we search for other worlds? Because exploration is part of human nature. Because we want to know whether we are alone in the universe. Because one day, discovering signs of life on a distant planet could become the greatest discovery in human history. And perhaps in the long term, our species may need alternatives in order to survive. In reality, the real question is this: will we be able to protect this place? Searching for Earth 2.0 does not mean giving up on Earth. On the contrary, trying to understand other planets shows us just how fragile and precious our own world truly is. Perhaps one day we will reach the stars, but until then, this is the only true home we have.